Hello, grade 9s. Today we're going on to exponential equations, working from slides 52 to 56 from the equations PowerPoint. Okay, so with these ones, they're a little bit different from the equations that you've done before, because now the x, or the unknown, is going to be in the power. Okay, and I'll show you how we deal with something like that. So if we look at the first example, they're asking us to solve for x, and it's 3x is equal to 3 to the 4. Okay, now what I want you guys to notice here is, here we have a base and there we have the exponent. Okay, and what we're going to do is we're going to try and get the bases, these things, the same on both sides of the equals. If they're the same, and you can see we have an equals, so 3 is equal to 3, that means that the exponents must be equal. Okay, so for this one here, therefore x must be equal to 4. Okay, if we go into example B, solve for x, 6 to the x is equal to 1. Now this one we got a bit of a problem, because it's not the same as the first example where our bases were the same, so we could just equate the exponents. Here our bases are different. We've got a 6 and we have a 1. So what I have to do is I have to make the bases the same. In other words, I must have 6 to the x equals 6 to the something. Okay, and I had to make it 6 because my variable is on this base here. So I've made that one 6, made this one 6. I have to sort out this exponent now. Now, if you go back to from last year's work, you learned one of these laws, that a to the 0 equals 1. Okay, anything to the power of 0 is 1. So that means it's 6 to the power of 0, because 6 to the power of 0 will give you 1. Now, bases are the same, 6 and 6. That means that the exponents must be equal. So x must be equal to 0. All right. Going on to question C. We have 2 to the x equals 8. Now, I need to have both bases to be 2, because this base here has my variable. Okay, so I need a 2 on that side. Now, 2 to the power of what will give us 8? It'll be 3. Now that our bases are the same, the exponents must be the same. Therefore, x must be equal to 3. Question D. 5 to the x is equal to 1 over 25. Okay, now this one I'm going to treat a little bit differently, because we have this fraction here. I need my base to be a 5, because that's the thing with the variable. Don't worry about the 1. What I want you to do is I want you to make that one base 5. Okay, so 5 to the power of what will give you 25? It's 2. Now, we can't do what we did here and now say that, well, x is equal to the whatever, because we don't have that base and base like what we had here, base, base. So what I'm going to do is I'm going to use another one of your exponent rules, and that said, if you have 1 over a to the m, and I bring it to the top, that would give me a to the minus m. Remember, if you swap their places from top to bottom or bottom to top, their exponents change their signs. Okay, and that's what I'm going to do here. So this is 5 to the x equals, and I'm going to bring this to the top, and we get 5 to the minus 2. Now my bases are the same. That means the exponents must be equal. Therefore, x is equal to minus 2. Okay, moving on to the next example. We have 7x to the minus 3 equals 49. Okay, now there's our base with the variable in it. Don't worry about the -3. It's part of that whole variable thing, okay? So I need both sides to be base 7, okay? So 7 to the power of what gives us 49? 7 to the power of 2. Now that the bases are the same, our exponents must be equal, okay? So just like the previous examples, I took this one equals this one. Going to do exactly the same thing. So this one's exponent is x minus 3 equals 2. Now what we can do is we can solve for x. I take that 3 to the other side and it becomes a plus. And we get x is equal to 5. All right, grade 9s, what I would like you to do is exercise 5.4, the left-hand side and the right-hand side for me, please. Thank you.